Welcome to the Nordson ASYMTEK booth here at IPC Apex. I'm joined by Garrett Wong, who's the production manager on the dispensing materials. Nice to meet you, Garrett.
Thanks. Nice to see you again, Trevor.
Now, we're standing here in front of course, the Spectrum 2, which is your latest dispensing system, which is fitted with the IntelliJet jetting system. Can you perhaps give us a description of some of the more recent updates to that system and demonstrate maybe some of the friendly nature of the changeover with the valves?
Will do. My pleasure. So the Spectrum 2 platform is, again, an evolution of our previous Spectrum 1 platform, which now it's a higher accuracy, about 35 microns for wet dispense accuracy, including your motion system, your vision system, and your valve system for placing individual dots or lines of material. For this, we've also implemented the new IntelliJet onto the platform, and coupled with our new monocle vision system, this is now a Spectrum 2 Premier system. And so it's a higher grade platform for a lot of our advanced semiconductor packaging customers, or customers who are doing a lot of more technically difficult applications, jetting into small gaps, narrow dispenses, moving into small dot sizes. So this is really a package that's really built around those specific needs. The IntelliJet is able to do very small dot sizes at very high frequency. It was really built and tested around underfill type applications. We've seen a lot of success recently with wafer level underfill using the IntelliJet on the Spectrum 2 Premier. And a lot of this is around jetting into these really narrow gaps on a wafer, doing underfill with high numbers of dots. And part of the reason that they ended up choosing the IntelliJet for it is because the IntelliJet is able to last significantly longer than any other jet that's on the market, whether it's a piezo or a pneumatic jet. The jet in our lab has already tested over 5 billion cycles. And so this is probably 1 year, a little over a year's worth of full-scale production, running at over 1 million dots an hour.
Right. That's incredible. I mean, but one of the reasons for that might be that there are a small number of real moving parts in the assembly of the system.
So one of the big benefits of the IntelliJet system is also the new cartridge system for the IntelliJet, where we're able to switch out the wetted fluid path consumables by removing the heater boot, and then the cartridge system just disconnects with a screw-on lure fitting.
Right. So the consumable parts are these parts here and here?
Well, so the heater block itself is not really consumable. It's all the consumable parts is really in this unit right here. Okay. This unit can be separated into two halves to allow you to clean it, to be able to inspect and ensure that you have a completely cleaned out and ready to go cartridge at any given time. 2 units come with every valve, so that when you're in production, you take your used cartridge off, you put the new one on, and it easily attaches back to the valve.
What would you clean it? I mean, how would you clean these?
So you take the cartridge apart, put it into an ultrasonic bath, and then leave it in the ultrasonic bath for maybe 5-10 minutes with an appropriate solvent for the fluid that you're running. And then you can pull out the ultrasonic bath, do an inspection, put it back together, and return it to production.
So, what about talking about the speed of the system? I believe that there's been a speed increase. So,
So with the 1,000 hertz frequency on the IntelliJet, it does run significantly faster for a lot of underfill applications. In this example that we're showing on the machine, we're comparing our old speed that we would have gotten with our DJ9500 running at 200 hertz compared to the speed that we can get now with 1,000 hertz running in the same pattern. We're probably seeing 80% more, maybe more, in UPH improvement for this type of application.
Talking about materials, Garrett, what sort of viscosity of materials is it able to handle?
So we've typically been working with a lot of underfill materials initially, but then we started testing a lot of silicones. The valve was really built around being able to jet a lot of more higher viscosity materials. We're still exploring some of the upper limits for where we can go with the valve, looking at some of the damming materials, some other paste materials. We've also done silver epoxies, UV curable, precise coating type materials as well, but those tend to be lower viscosity. The ability within the valve to control the actuator for the pin velocity, to be able to control the distance that it's moving at for stroke distance, the ways that it opens and closes, and the timing for these things has really been a significant advantage for us for not only achieving small dots, but also achieving very narrow in-air stream widths, but also being able to do that with a large dot volume, which helps to improve UPH further for a lot of these underfill type applications.
Well, I want to thank you for giving us a run through on the latest improvements to the Spectrum 2, and thank you for joining us today.
My pleasure. Thanks a lot, Troy.